So guys, we are going to start with a new unit today, which is called as basically optics. Optics is basically what? It's a branch of science, or basically it's a branch of physics, generally, which deals with what? With the study of light and its properties and various phenomena. Associated with it. So basically this optics, Sir Joshua won't be able to attend. Why?
Sir, I don't know.
Okay. So basically we have ray optics. Then we have, optics can be classified into three different types. We have ray optics, wave optics, and then the last one is basically the quantum optics, right? So in 12th grade we have mainly this and a glimpse of this, not much in detail. Although there is one chapter which is completely based on quantum optics, the dual nature of radiation, dual nature of light, right? Yes or no, people? So we will be starting with the ray optics today. And what is this ray optics? Also called as geometrical optics. Guys, this is also called as geometrical optics.
Can you scroll a bit up, please?
Yeah, sure.
Yes, sir. Thank you, sir.
So in the case of geometrical or ray optics, basically what do? We consider light. Here we consider light to be moving in a straight line path. This path, when represented diagrammatically, is basically called as what? Is called as a ray of light. And this property due to which the light travels in a straight line path is basically called as rectilinear propagation of light. So basically ray optics will be completely focused on the rectilinear propagation of light. And what is basically the rectilinear propagation? It is the property where we assume it travels in a please remember this geometrical optics or ray optics supports the particle nature of light. Suppose the particle nature of light, where we consider ray as a particle. In the particle, whenever it is moving with certain velocity, the path is basically shown with the help of a ray, right, guys? So ये याद रखना कि light, it has dual nature. It behaves as a particle as well as a wave, right? So ray optics is basically the branch which will focus completely on the particle nature of light, will not consider the ray as energy, will just consider it as the path on which a particle moves, right? Later on in quantum optics, people define those particles as photons. Yes or no, people?
Yes, sir.
So we'll generally consider about this particle nature of light. Anyways, so what happens whenever this ray of light meets a surface separating two mediums, two media, then reflection or refraction or dispersion may also occur, but abhi I am not including dispersion as of now. Then reflection, refraction may take place. So basically, we are going to study about this reflection and refraction and an image. In spite of is you can write an image may form, right? Please remember, guys, ray optics focuses on rectilinear propagation only. Either light, the tendency of light to travel in a straight line. You can say this particular thing. It is the property or tendency of light where we assume it to travel in a straight line path, or you can say the tendency of light to only to travel in a straight line path. Shall I give you the technical definition? Is it fine? Guys, shall I give you technical definition?
It's fine, sir.
So you can write the tendency of a light ray to travel in a straight line in a one particular medium is basically called as what? अच्छा, एक और चीज this assumption of particle nature है ना, where light travels in a straight line, this assumption of rectilinear propagation is valid only till the thickness of the obstacle in the medium is much larger as compared to its wavelength. So this assumption of ray optics is only valid till the time the thickness of the obstacles is way larger as compared to the wavelength. For example, suppose if you have any object or any source from which you are assuming that the light is coming in a straight line path, that implies that medium particles are also way bigger, or whatever objects which are placed in that medium are also bigger as compared to the wavelength of the light, right? So that is what is meant by this particular. So geometrical optics. Acha, by the way, this is a further classification, है ना? कभी मतलब, in case if you don't want to do it like this, you can either have geometrical optics, or you can either have physical optics. And this physical optics has two types: wave and quantum. Is this clear, guys? So ultimately, you have these three as your main distribution. But in case if someone asks, is this clear?
Yes, sir.
Okay.
Yes, sir.
Now, please let's write about a light ray and a light beam. A beam of light or a ray of light. We'll write about that. What is the light ray? ray के बारे में you can write it is the path, please remember, along which light travels. ठीक है? It's just a hypothetical concept है ना, actually में you won't be seeing the lines coming and all. It is just to understand this ray optics or geometrical optics a little bit better. We have assumed this concept. Just to understand magnetic field, we assume magnetic field lines, right?
Yes, sir.
Just to understand the magnetic field, we assume magnetic field lines. Similarly, just to understand how exactly the light is moving, we are assuming rays. So it is represented by drawing an arrow, by drawing a straight line with arrow. What does this arrow represents?
The direction of the
Yeah,
light.
exactly, representing the direction. Now, similarly, what is a beam? Beam is basically a bundle or a collection of light rays is called as a beam of light. Okay? There are three different types of beam. The one is basically, this one is called as control C, control V. Can you see, guys? This one is basically called as a parallel beam of light. Yes or no? Everyone, is this clear? This is called as basically a parallel beam of light.
Yes.
Then you have these type of beams as well. Proper, you people draw it properly, okay? मैं properly नहीं बनाऊंगा अब ज़्यादा. And then can you see this type of beam? This type of beam is basically called as a diverging beam. Diverging beam is something which is diverging away from one particular point, right? And then after this we have what? This is what? A converging beam. Is it clear, guys? Three different types of beams. Clear?
Yes, sir.
Similarly, there is something called as a pencil of light. Pencil is basically a narrow beam of light, is basically called as a pencil of light. Anyways, please remember, light rays, they don't exist actually. It's just an hypothetical concept which we have devised so that we can understand light a little bit better. Is this clear? Is this clear?
Yes, sir.
So please remember, with the help of geometrical optics, we can explain, geometrical optics can explain. First is reflection of light. The second is refraction of light. And the third is dispersion of light. Okay, so basically geometrical optics will only be able to analyze these three phenomena, nothing else. After that, wave optics will come into play, right? Shall we start, guys?
Yes, sir.
Now, second part is basically what? Uh, Please give us the heading. Reflection of a light. What is reflection of light? Right, 10th grade stuff. Please remember. Batao.
Bouncing back of light from a
So
circle.
the basic part I'm not discussing that much in detail. सबको पता है ये bouncing back of light in the same medium after getting incident on a just striking uh, an interface between two medias. Okay. There are certain laws of reflection based on that. So if you have any surface, whether it's a mirror or any particular surface, then what will happen? The light ray will come like this, and after reflection it will go like this. Everyone is aware about this particular thing, no? सबको पता है ये तो.
Yes,
Incident
sir.
ray, reflected ray. What is this? What is this point called?
Normal.
This point is called as the point of incidence. What this normal is called as normal at the point of incidence. This angle is called as angle of incidence. This angle is called as angle of reflection. Right?
Yes, sir.
So on the basis of this particular thing, we give. So there is in the plane in which all of them are drawing as basically called as the plane of incidence, right?
Yes, sir.
I'm doing this thing fast so that at least your this part gets clear, है ना? ये जो basic था ये तो I'm not explaining in much detail, right? Now first part, first laws of reflection, angle of incidence is always equal to what? Angle of
Reflection.
Reflection.
reflection हमेशा always, it's a law, है ना? So angle I should be equals to angle R always. The second is the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane, and that plane is basically called as what? The plane of
Plane of instance.
incidence. There is a mathematical form for this law as well. Please remember. Acha, can you see over here? Suppose the normal vector is like this, है ना? So if suppose this is n cap is basically a unit vector in the direction of the normal at the points of incidence. This is the incident ray. So can I say IR cap is basically a unit vector in the direction of incident ray? Yes or no?
Yeah.
And similarly, normal unit vector is in this direction and reflected ray is in this direction. Yes or no? This angle is R and this angle is I, right? Yes or no? So basically this angle will be 180 minus I. Yes or no, guys? But please remember, I have taken unit vectors, so this will not matter later on. So what is this? Can you see? If I do, this cross n cap should be equals to RR cross n cap. Can you see cross product, guys? Incident ray is like this. Normal ray is like this. So can you see from here to here? The thumb is pointing towards me.
Yeah.
है
Yeah.
ना? And similarly, RR, N is over here. So here also the thumb is pointing towards me. In both the cases, the answer will be a unit vector only. है ना? And can you see the last term, the sine theta? Sine theta term, can you see over here? Sine of r and sine of pi minus I. 180 minus I is also I only.
Yeah, yeah.
So ultimately it will going to be the same thing. So this is basically the mathematical form for the second law, which is second law of reflection. Is this clear? So you can write this as your vector form of second law. Is this clear? Please write. Guys, there is a homework for you in the next class. If you want ray optics to be complete, 10th grade की किताब में से, open up 10th grade NCERT, and I want you to remember at least all of the diagrams, ray diagrams which the mirror has. How many diagrams are there? Six for concave mirror,
Concave. Yeah.
and 2 for convex, right?
Yes,
Yeah.
sir.
है ना? तो those 8 diagrams should be in your brain, because I don't teach it like that, है ना? I don't teach diagram by diagram. I basically teach like region wise, region 1, region 2, region 3, region 4, है ना? Clear है?
Okay, sir.
Okay.
Okay, sir.
चलिए, तो वो diagram shall be. अच्छा, does anyone has noticed this particular thing? Has anyone ever asked the teacher कि why are there 6 diagrams in convex mirror, concave mirror, and 2 diagram in convex mirror? Why is it different?
Because the image is just virtual in all the other cases for convex also.
ना बेटा, ऐसा नहीं है. It is because whatever diagrams you have drawn, no, those were for real object. Objects
Okay.
can be virtual as well.
Oh, okay.
ठीक है?
Objects can be. Yeah, that's what we see in compound lens, right?
चलो. So I think these laws of reflection is pretty much clear to you. Then after
Yeah.
this, there is types of reflection. What is this type of reflection? There is one which is called as regular reflection. What is this regular reflection thing, guys? Hello, people.
When light is reflected from like a smooth surface.
Exactly. Regular or specular reflection is basically when light is reflected from a smooth surface. Light reflected from smooth surface. So I think you might have drawn the diagrams for this. You also might have studied in grade 10. And you have irregular or diffused reflection, right? So light reflected from rough surface. See, from smooth surface you generally don't see that much. You generally see the reflection from a rough surface, right? Tell me, can you give me an example of smooth surface? It's basically mirror. It's basically still water surface, right? Then you have lustrous metallic object surface. Yes or no? Etc. So these are basically what your smooth surfaces, right? Can you give me example of rough surface? Table, laptop, whatever which you are able to see, does it emit its own light? Guys, can you see the pen in your hand? Can you see the paper, what exactly you are writing, the laptop, the walls? All of these objects, they are not smooth. If they would be smooth, then you would be seeing your reflection in that particular thing. But can you see your reflection in the wall nearby? Can you see the reflection in the wall nearby? अरे हाँ है ना,
No.
but you can see the ball, right?
Yeah.
So basically what is
So-
happening, how are you able to see this light from other source is basically reflecting on that particular surface and then reaching your eye. Are you getting my point? So that is how you are able to
So
see these rough surfaces. So mostly all of the surfaces which you are able to see are basically rough. Okay, rest everything is smooth, the remaining are smooth. Okay, so etc etc. So I think the diagram was also there. Do I need to draw the diagram for this? You remember there was a parallel beam of light, and when this parallel beam of light was incidented on this parallel beam went like this, parallel again, right? Everyone remember this particular thing? In this case, do
Yes,
you
sir.
see over here the angle I1 is equals to R1, the angle I2 is equals to R2, and the angle I3 is equals to R3. But what will happen in the case of regular reflection, I1, I2, I3, if it's a parallel beam, then I1, I2, I3 are equal. Also, that implies R1, R2, R3 be equal hoga. Is this clear? Is this clear, guys?
yes,
And
sir.
here I1 is equal to R1, I2 is equal to R2, and I3 is equals to R3. But in the case of a irregular reflection, what will you do? Suppose if you have a rough surface, then if you incident a parallel light, then what will happen? Guys, please you draw perfectly, hai na? This is 10th grade portion, so I'm not wasting much time on it. So can you see in the case of irregular reflection, the light rays go like this, right? Are yes or no? These are all incident rays, these are all incident rays, this is reflected ray, and these all are reflected rays. Clear? In this case also, I1 is equal to R1, I2 is equals to R2, and I3 is equals to I3, R3. So can you see over here, in case of irregular reflection also, the laws of reflection are valid, but here I1 is not equals to I2 and it's not equal to I3. So can you see the difference between both of them? So generally people ask a question for this particular thing कि are the laws of reflection valid in the case of irregular reflection as well? तो तुम्हारा आंसर क्या होना चाहिए? Yes, they are valid, but even if we draw a parallel beam, still the angle of incidences for different rays will be different. That's why the reflected rays are at different angles. Anyways, clear? Is it clear, guys?
Yes, sir.
So this was basic 10th grade portion. Abhi bhi still 10th grade portion is not over. 10th grade portion still will be there. Please write down heading the concept of object and image. है ना? Please remember, in geometrical optics or in ray optics, object is defined as the point of intersection of all the incident rays on the optical device. So object is defined as the point of intersection of all the incident rays on that optical device. Okay, or basically you can say this particular thing, object is the point all incident rays are coming, or appear to come. Okay, and now these incident rays can be of three different types. They can be parallel, they can be converging, they can be diverging, right? So based on this particular thing, objects are also classified into three types. First type of object is basically called as the objects at infinity. When the object is at infinity, you cannot say about the nature of that object because इतना दूर है कैसे दिखोगे, right? So the nature is not defined when the object is at infinity. When the rays are parallel to each other, can you see over here when the rays are parallel to each other? Whenever there is a parallel beam, guys, can you see a parallel beam of what lights? Which lights? A parallel beam of incident rays.
So how
And
is an object formed if all the rays are parallel? There will be nothing formed, right?
there will be formed, but at infinity.
Okay.
है ना? So suppose if this is your optical device, this is the device, है ना? It can be a lens, it can be a mirror, it can be anything. So this is, if I say this is your optical device, so can you see on this optical device, the object may lie over here, or the object may lie over here, right? So you cannot define exactly where is the object, since the light rays are parallel, so the infinity object is at infinity. Is this clear? So you'll simple write it as the object is at infinity whenever light rays are parallel, incident rays are parallel, then you just say object is at infinity and the nature is not defined. The second type of case is basically when the beams are diverging away from each other. Let me draw diverging beams, please. So these are your diverging what? Diverging incident rays. So can you see over this particular point, all these incident rays, they are appearing to come from a one particular point. It may be a, many points over here, but this point of intersection of all these rays when they are actually coming from this particular point, then this point is basically called as an object. So here in this case, this is a real object. Real object is basically when incident rays are actually coming. Okay, can you see over here, if this was the point, then this rays have already crossed this particular point. So can you see on producing them backwards, I'm getting this object is real. So always remember, whenever the beams incident ray beam is diverging in nature, whenever the incident ray beam is diverging in nature, then the object will be whenever the incident rays are diverging, that means the object will be real. Is this clear, guys? Is this clear? The third case is basically a virtual object. Can anyone tell me what is a virtual object? When the light rays are
converging.
I'm drawing only 3 rays. Is it fine? Guys, I'm drawing only 3 rays. Is it fine?
Yes, sir.
So can you see if this is an optical device? Then can you see this particular point, guys? It is again the point of intersection of these points, right? These incident rays, it is the point of intersection of these incident rays. But can you see over here, in this case, our incident rays are basically converging in nature. So actually these rays are not meeting. Why exactly they are not meeting? Because this optical device will change their way, right? This optical device, whether it is reflection or refraction, will it change the direction?
Yeah.
Anna? So it will change the direction. If it changes the direction, will they actually meet at this point? Never, right? So they are here in this case, incident rays are appearing to meet. Actually they are never meeting, right? Incident rays are appearing to meet. So hence this object is virtual. So you can say this particular thing: whenever incident rays are converging, then the object is always virtual. Please write till here and then we'll do the image.
So if
So
the lines are not actually meeting, how exactly are we seeing the image?
we are
Is
not
it the reflect? Yeah, yeah.
image, beta image किससे बनती? Are image defined with the help of incident rays? Images are defined with the help of
Reflect rays.
reflected or
Okay.
refracted rays. Then
Then how can
according
a virtual object be formed? Like, can you give an example where this is happening? Virtual object.
suppose there is a mirror, plain mirror, है ना? And let's say
Okay.
a light ray incident ray is coming like this and another incident ray is coming like this. Can you see the incident rays both are basically converging in nature, right?
Yeah.
So can you see over here, if I produce these lines in the forward direction, so here this is basically your virtual object, and then after reflection what will happen? This light ray, since it's normal incident, it will go back like this, and this light ray will go something like this. Yes or no?
Yes.
So can you see over here, these light rays are actually meeting, these reflected rays are actually meeting at this particular point, hence this will be a real image. Till 10th grade you might have heard this particular thing. Now you can form with the help of a real object, you can form a real image. With the help of a real object you can form a virtual image, right?
Yeah.
With the help of a virtual object again you can form a real image, and with the help of virtual object you can form a virtual image as well. Everything is possible.
But basically, it's the real object that is.
Hello, Satvik, your voice is Satvik, hello. Now I can't hear you, bro.
Hello.
Now I can hear you.
Okay. So actually, the light rays are coming from a real object, and those they are like the virtual object is just being formed. Like it's just for
Ha,
name sake. I think
ha,
we are making
ha,
it.
ha. Virtual objects don't exist actually. That is why they are virtual, no? So the
Yeah,
light appears to meet at that particular point. For example, suppose karo, how are you able to see yourself in the mirror? For the
because of the
mirror,
virtual
that
image.
image is there, right?
Yeah.
Actually में वहाँ पे तू खड़ा है क्या पीछे mirror के?
No.
Are you standing exactly behind the mirror? No, na. You are standing
No.
in front of the mirror. Your image is behind the mirror, right?
Yeah.
But is your eye able to see you, or is your eye able to see your image?
See the image.
So basically the virtual object which is formed by the mirror is acting as a real object for your eye. It's all a
Oh.
matter of this optical device as well, no? तभी तो हर एक जगह पे I am drawing this optical device.
Okay, so it's like one is reaction force, one is action force, other is reaction force. ऐसा करके हम one thing will say is the real object, other is the one thing will say is the object, other thing will say is the image.
Incident ray will tell you about the object and reflected ray will tell you about the image.
Okay.
है ना? and all of this is with respect to that optical device which I'm drawing in the middle.
Optical
That
device.
optical
Okay.
device can be anything. It can be this thing. It can be anything, yeah. है ना?
Okay.
So
Yes.
anyways, we'll talk about these diagrams later on as well. Is this clear, guys? Object clear hai? Don't worry, virtual object will get clearer over time. This is something which you are learning new. It will take time to adjust. है ना? Real object, real image, virtual image, you are comfortable, right? Because 10th grade में पढ़ लिया हमने. Virtual object कभी पढ़ा नहीं है, इसलिए a little bit of uncomfort will be there at the beginning. But later on, even this will be, not there. Anyways, I think object is pretty much clear to you. Shall we discuss about image now? People? Now let's discuss the concept of image. The concept of object was already done. So now let's do the concept of image. What is image? In geometrical optics, what do you define as the image? We can say this particular thing: after incidence of light rays on an optical device, the light rays reflect or refract and move away from the optical device. Is this true? Is this true, guys?
Yeah.
So basically for this optical device, image can be defined as the point of intersection of these reflected or refracted rays. So just like object, image is basically what? It is basically what? It's the point of intersection of reflected or refracted rays. But please remember, both object and image, both are defined for a particular
Optical device.
optical device. So the object for one optical device or the image for one optical device may act as an object for some other optical device. This is what is happening in the case of you seeing yourself in mirror, है ना? So how many optical instruments are involved? The mirror and your eye. Two optical instruments are there. Yes or no? Are hi na. So when you see yourself in the mirror, basically for the mirror, you are the object, and it forms an image behind the mirror. So for that mirror, that is the image, right?
Yeah.
Please follow carefully, है ना? How many optical instruments are involved when you see yourself in the mirror? Two optical instruments are involved. First is your eye, second is the mirror. Yes. Now for the mirror, the light ray from any particular source may reflect on your body, and then from you it is going towards the mirror, right? So basically for the mirror, you are a real object, and mirror, it will form a virtual image of yours, right? Will it form a virtual image of yours?
Yeah.
Now when this mirror has formed a virtual image, then what will happen? Now your eye, it's in front of your eye, right? That object, that image of yours which was formed in the mirror, will it be acting as a real object for your eye? Will it be
As a
acting?
virtual object.
No, the image for your eye. For your eye. I'm not talking about mirror. Here, यहाँ पे ऐसा वो ही नहीं. Although that object is not existing, but देखो actual में that is not tangible, right? but still optics is nothing about touching. Optic is about seeing, right?
So that object is being formed by not actual intersection space, so it should be virtual object.
नहीं ना बेटा, मैं अभी भी बोल रहा हूँ, image or object is defined for one particular optical device. The virtual image which is formed because of the mirror is acting as the real object for your eye. It's in front of your eye, ना?
Okay.
तेरी आँख के पीछे बन रहा है, बता?
No, it's
getting my point?
okay, like that. Okay.
Okay. So basically, that virtual image which is forming with respect to the mirror is basically acting as a real object for your eye. And then an image of that real object is a real and inverted image is forming on your retina inside the eye. And then, you know, some cells are sending electrical signals to your brain where your brain is interpreting the image. Are you getting my point? So please remember, this concept of image and object is specifically for an optical device. For one particular optical device, a virtual image can be acting as a real object for another device, right? Is everyone clear about this particular point? Image and object both are defined for one particular object. Please remember. Now, you can also define it as, you know, it is the point of convergence of it is the point of convergence or apparent point of divergence of rays after they interact, or after of which rays, by the way, guys, which rays? Reflected or refracted rays after they interact with a given optical device. Okay, again, based on the three different types, I have three different types of images as well. So this time I'll not be taking much of this space, I'll be just drawing very shortly. Now suppose this is your optical device, and whether it is reflected rays, so I'll draw it like this, yes or no? And if it is refracted rays, then I'll draw it like this. If the incident rays were like this, then reflected ray will be like this and refracted ray will be like this, yes or no, everyone? So remember this particular thing. Suppose I'm drawing for reflection only, suppose I'm drawing for reflection. Suppose if I have these are your reflected rays, all of them are reflected rays. So let's say this is your optical instrument, whatever, wherever the optical instrument may exist. If these are incident rays, then always you'll say the image is at infinity. Image can be anywhere. It is at infinity, so it can be positive infinity as well as negative infinity, pata nahi kahan hai, right? And the nature of the image is not defined. Is this clear? First type of image is basically image at infinity. Second type of image is basically what? Suppose if the optical device is this, and let's say the image is like this. Can you see all these images, guys? They are actually going to meet at one particular point, right? So when they actually meet at one particular point, then this image is basically called as what? A real image. This is reflected ray, this is reflected ray, this is right. Is this clear, guys? Reflected rays actually meet.
So image is defined as point of divergence, right?
Point of divergence or the point of convergence or the apparent point of divergence. So can you see this is basically the point of convergence?
Okay.
and in the next case it will be the apparent point of divergence. Whenever reflected rays are converging, then image is, and the last case is whenever reflected rays are diverging. So whenever reflected rays are diverging, this is your instrument, right? This is your optical device. So appear to it. Always remember, whenever reflected rays or refracted rays are diverging, then the image so formed is virtual. Shall I give you a summary of whatever we have learned till far?
So, I think in 10th, this image at infinity was, I think, defined as a real image.
वही तो मैं बोल रहा हूँ बेटा, तेरा 10th ग्रेड में तू बच्चा था ना, तेरे को समझ में नहीं आता है इन्फिनिटी का कॉन्सेप्ट. So generally NCERT has skipped that information. They generally say, okay, let's keep it simple for these students. These students will never know.
Okay.
So, but the point is, they are very clever. In 12th grade also, they will, try their best to hide the concept of virtual object. But कब तक छुपाओगे? Are you getting my point?
Yes, sir. So still, where will the virtual object be actually used? Because even in the case when you're seeing in the mirror, you're seeing a real object. So where is virtual object coming?
अब जैसे for example the diagram which I drew for virtual object, अब मुझे एक बात बता, when the incident rays were converging in nature, right? So what the location of that particular object important, right? अब if someone asks you, can a plane mirror form a virtual image? Can a plane mirror form a real image? So what will be your answer generally? 10th grade के अनुसार?
I will say no.
Exactly, but you just saw I drew the diagram in which a real image was getting formed, right?
Yeah.
So in adhura knowledge, 10th grade is half the knowledge of what they give generally. And I'm telling you this particular thing, Abhi, you will be surprised in this particular thing. There are total of 16 diagrams. There are total of 16 diagrams just for mirrors. Out of which, how many have you studied? Only 8, right? So they have given you only half the knowledge. बचा कुचा half 12th में मिलता है generally, teachers को देना चाहिए, but generally everyone skips. Even I skip, but I explain region wise, na? So that gets covered. I don't teach the ray diagram like, कि बेटा if the object is at center of curvature, the image will form at center of curvature. No, अरे वो सबको पता है. I teach it a little bit differently, So anyways, I think image and object pretty much clear to everyone, है ना? People?
Yes.
So guys, ठीक है? So if you have converging incident rays, Anji, converging incident rays, virtual object. If you have diverging incident rays, then real object. If you have converging reflected rays, then real image. And if you have diverging, then virtual image. Are you understanding how exactly to read this particular thing? Converging incident rays, virtual object. Diverging incident rays, real object. है ना? People, are you able to read this?
Yes, sir.
चलो लिख लो फटाफट. after this, I guess I feel of view. So field of view will come later on. Sorry. Guys, are you done? Please write it carefully. And then write the heading. And give me 2 minutes, I'll be back. Done, guys.
Yes, sir.
Yes.
Plane mirror. What is a plane mirror? Everyone already knows what is a plane mirror. It is a piece of flat glass with, we generally. Shall I draw anything for it? Suppose a very thin plate of glass is there, and on this thin plate of glass, what will you do? On one side, you'll, paint a reflecting surface. It can be this reflecting surface, maybe the reflecting liquid can be of anything. Reflecting coating on one side, right? Can you see reflecting coating on one side? It can be of silver, but generally silver is not used because silver is costly, right? Then people use
Sir.
mercury, etc. So basically they coat it with this silver lining, and after coating with this silver or mercury, basically they double coat it with a paint. Double coated with paint means what? Just to hold that mercury lining over there, people double coat it with the help of paint. Paint, it's a adhesive substance, right? Paint is adhesive, right? अरे हाँ है ना, चिपकता है कि नहीं? Does paint stick to an object?
Yes, sir.
So basically, just to hold that silver or mercury lining, we double coat it with the help of a paint. So what happens? Ki when light rays go, from the, light rays try to come from this side. So what happens? They basically get this particular surface. They get refracted a little bit, then get incident over here, from where they get reflected back, then again refraction, and then it comes out, right? But to keep this distance very small, this plate is very thin. So these are basically called as what? The mirrors, right? Mirrors, they have a reflected, a non-reflecting side. This is basically the non-reflecting side, or basically the silvered side, and there is one reflecting side, which is this side, right? Yes or no, people?
Yes, sir.
How do we draw a mirror symbolically? Like this. Everyone already know this part, right? Shall I directly
Yes,
go to
sir.
the question part? Hello. See the questions and then we'll later on learn about the properties of image formed by a plane mirror later on. So suppose I have a mirror. Is everyone able to see a mirror? A light ray is incidented at an angle I. ठीक है? Guys, a light ray is incidented on a mirror at an angle I. The question is find the angle of deviation of this ray of light. So by what angle will this ray deviate? है ना? So basically what do you mean by this particular thing? If the light rays goes like this, then can you see the original path was this? Was this the original path? If this mirror would not have been there, then this, can you see? Due to the mirror, the light deviated by this much angle. So ये angle कितना? अरे one line answer. It's a one line answer, guys.
180.
180 minus
2i.
exactly. Delta is equals to 180 minus 2i. Why 180 minus 2i? Because this angle will also be equal to I. Angle of incidence is equals to angle of reflection, and this complete angle is 180 degree. So can you see whenever a light ray gets reflected back from the mirror, then the deviation so produced is basically how much? 180 degree. अच्छा, it is denoted by delta. ऐसा छोटा delta. Okay. Is this clear?
Yes, sir.
Okay. Next question. Suppose there is a mirror. Everyone is able to see the mirror, right?
Yes, sir.
This is the incident ray. Oh, sorry. This is the normal at the point of incidence. And let's say this is the incident ray. Wow, what a straight line I drew. Take note. And then this is the reflected ray, right? So suppose
Yes,
we
sir.
have Hello? Yes, tell me. Hello. So suppose this particular thing, if I have a laser and I have pointed this laser at this particular mirror, so what happens? This reflected rays goes like this, following the normal laws of reflection, right? Yes or no?
Yes, sir.
Now the question is, keeping the position of the laser fixed, if the mirror is rotated at an angle, rotated by an angle theta, then find the angle by which the reflected ray will rotate. Basically, if I rotate the mirror by an angle theta, wait a second. So can you see, guys, about the point of incidence only? Can you see this is the point of incidence? About this point of incidence, I have rotated the mirror by an angle theta. Then can anyone tell me where exactly this reflected ray will move? This reflected ray will also be tilted by certain angle, right? So I want you to find out by what angle will the reflected ray rotate and in what sense. Matlab, since can you see over here in the diagram I have rotated the mirror clockwise or anti-clockwise? Yes or no, guys?
Yes, sir.
So rotated by an angle theta anti-clockwise. Then find the angle by which the reflected ray will also rotate and in what sense. The answer is out of these four options. And again, it's not a very big question to be solved. थोड़ा सा logic लगाना है. The question is theta anti-clockwise. The answer is theta 2 theta anti-clockwise. The answer is theta clockwise, and the answer is 2 theta anti-clockwise. So out of these four options, there is one answer. Oh, sorry. Out of these four options, there is one correct answer. Please start doing it and tell me what is the answer.
So will it rotate anti-clockwise by theta?
No. You mean to say option A? है ना?
Yeah.
Wrong.
Yeah.
So will it be B?
Theta 2 theta anti-clockwise, right?
Yes, sir.
That is the correct answer. How? Yes, can you tell me how? Guys, please look over here. When this theta is, the mirror is rotated by an angle theta. So let's say the initial position of the mirror is basically this mn, right? And the new position of the mirror is basically what? M dash, n dash, right? This point is same, and I'm not moving this incident ray, right? Yes or no? Now tell me, when you rotate this mirror by an angle theta, what thing will rotate along with this mirror? Which thing will rotate along with this mirror? Will the normal also rotate by the same angle theta? Right? Yes or no?
Yes, sir.
So basically, if I say n was the initial position of the, let's name the mirror as something else. delete and delete. Let's say the mirror is LM. Okay, so LM and the normal was N. Is it clear, guys? So let's say
Yes,
the new
sir.
position of this becomes L dash, M dash, and the normal becomes at N dash, right? This angle is 90 degree. Now, can you see over here, if initially, this was the source from where the light is coming, initially was this thing happening? This angle between N was basically equals to how much? This angle was the angle of incidence, right? Initially, this was the angle of incidence, right? Yes or no? People, hello?
Yes, sir.
Everyone, is this clear? Can you see this is the angle between the incident ray and the normal initial angle, right? So this angle was I. But when this thing rotated by an angle, can you see over here? Only this is the remaining I dash.
Yes, sir.
This is the new angle of incidence, right? So can you give me a relationship between I, theta and I dash?
I minus theta will be I dash.
So I dash plus theta is equals to I, and from I dash will be equals to I minus theta. Yes or no? So the new angle of incidence is basically I minus theta, right? So the new
Yes.
reflected ray will go somewhat like this. Will the new reflected ray be like this? R dash with at the same angle from the new normal, which is I dash, right? Yes or no?
Yeah.
Right?
Yeah.
So we understood this particular thing, that the new normal will also, this will be I dash, and can you see the previous angle was I? So this angle is also I. This angle is also I, right? From the previous normal and the previous refracted way.
Yes, sir.
Anna? So can you see and this particular thing, guys? I'll draw it for you. This was the initial reflected ray, this was the incident ray, and this was the normal. I'll try to draw it again for you. Na? So this was angle I and this was also angle I. Later on, what happened when you rotated the mirror, then this became the normal N dash, right? This became the normal N dash, but this was the angle theta. This became I dash, right? So the reflected ray in this case, it went somewhat like this. Yes or no? This is the new reflected ray. Yes or no, guys?
Yes,
So
sir.
if this angle is I dash, this angle is also I dash. So can you see over here? And this is the angle which they have asked you, delta. So can you see over here, this I dash plus this I dash plus this delta. So I dash plus delta is equals to, can you see this I plus this I is equals to twice of I, Anna? And from here, delta is basically twice of I minus twice of I dash, which is basically twice of I minus I dash. And what is I minus I dash? Basically theta. So hence your answer is basically what? Twice of theta. And can you see the mirror was rotated anti-clockwise? So can you see the sense is also anti-clockwise? So that is why B is your correct answer. This is the standard result now. Please note. First ये लिख लो, फिर I'll give you a note, है ना? So these questions are generally based on rotation of mirror. भाई वो लगा देना वापस, मेरा लैपटॉप का चार्जर है. हाँ, मेरा बंद हो जाएगा वो. तुरंत बंद होता है. उसको दूसरी जगह पे लगा ले. Guys, are you done noting now? समझ में आया question, guys?
Yeah.
Sir, can we do it like first I equal to the reflected angle, first wala, and then oh no, that is wrong. Okay, I got it. Nothing.
Chalo. So please write a note. These questions are basically based on rotation of mirrors, right? So please remember, if the angle turned by a mirror is theta about the point of incidence, keeping the incident ray fixed. So when the incident ray is fixed and you are rotating the mirror by an angle theta about the point of incidence, then the reflected ray gets deviated by an angle 2 theta in the same sense of a rotation of mirror. In the same sense of rotation of mirror. Clear? Acha, can you see both when the mirror was rotating in some time, the same time, this thing was also rotating, right? The reflected ray was also rotating, right? So can I say the angular velocity of the reflected ray is basically twice the angular velocity of the mirror? Hello people, can I say this? If incident ray is fixed and the mirror is rotating about the point of incidence by this much omega, then the reflected ray will rotate by कुछ चल रहा है incident ray is fixed. Is this clear, guys?
Yes, sir.
Shall I give you a next variant of the same question?
Okay. Yeah.
Now suppose if keeping the mirror fixed, incident ray is rotated by an angle theta, then reflected ray will deviate by a same angle theta in the opposite sense. So what do I mean by this statement? Is basically, suppose if I have a mirror, this is the normal. I'm not rotating the mirror this time. I'm rotating what? The incident ray. Na? So this is my incident ray and this is my reflected ray initially. And now let's say I have rotated the incident ray by an angle theta. And let's say I'm doing it anti-clockwise again. Hai na? So let's say this is my new incident ray IR dash. And can you see this angle theta by which I have rotated it? So this is very easy, right? When incident ray is rotated by an angle theta, can you see the angle of incidence has now increased? The angle of reflection will also increase, right? So can you see the reflected ray will deviate by a same angle but in the opposite direction? Yes or no?
Yes, sir.
So basically from here I can write angular velocity of reflected ray will be the negative of angular velocity of incident ray. But this is only valid when mirror is fixed. So are these type of questions clear to you? I can give it in the question format and then you can solve it. But I guess the concept makes sense to you now, right? Rotation of mirrors about the point of incidence, keeping one object same. Does it make sense now? Guys, does it make sense now?
Yes, sir.
Next we'll write is, please give the heading, properties of image formed by plane mirrors. So properties of image formed by plane mirror. First, the image distance is equal to the object distance. For example, suppose if I draw a diagram like this, say this is the mirror, plane mirror. I'll try to draw two diagrams, है ना? And then we'll do comparison. Control C, Control V. In the first case, guys, I'm taking object over here. If this object is over here, then can I send one incident ray over there? I'm naming this as O, okay? And one incident ray over here. So both of these are incident rays. Can anyone tell me what kind of object is this if these incident rays are what? They are converging or diverging?
This one is
Diverging.
They are diverging, so diverging incident rays form a real or a virtual object.
Real object.
So this is a real object in front of the mirror. So can you see this light ray, it will get reflected like this? Yes or no?
Yeah.
So this light ray will get reflected like this, and this light ray will get reflected like this. Yes or no? When I this image is formed. Can anyone tell me what is the nature of this image? Reflected rays. Can anyone see what are
Converging.
reflected rays? Can you see reflected rays are like this? Reflected rays are going away. Can you see the direction, everyone? Reflected rays are diverging. They are not converging. Can you see? Reflected rays going like this. Reflected rays going like this. So the reflected rays are diverging. Hence the image is virtual. Arey, just focus only on the reflected ray part. Just focus only on the reflected ray part, please. Don't focus on anything else, only the reflected ray. Shall I draw a good diagram? ऐसा कुछ बनाऊं क्या मैं अच्छा diagram? Guys, shall I draw it using scale pen?
No, sir, it's fine.
So can you see this reflected ray is going like this, that reflected ray is going like this. Both the reflected rays are diverging away from each other. Angle बढ़ रहा है ना? Can you see the separation between both the rays is increasing as the ray go forward? So hence they will be produced when drawn in the backward direction. Can you see images from this? Now see this very clearly over here. If this angle is I, this angle is also I. This angle is I, this angle is I, and if this is I, this is I, this is I, then this is also I. So can you see these two triangles which are getting formed are similar to each other, right? This distance is common, this angle is same, and it is this. So RHS congruence, 10th grade, I guess. Congruency, which grade? I don't know, whatever. So always remember in the case of this thing, can you see this was basically the object distance, which is denoted by U. If M, do you remember UV mirror formula? किसी को याद है? 10th grade में we have already said U is basically the image distance, V is basically the, ये याद है किसी को?
Yes, sir.
Sir,
u is basically the object distance and v is basically the image distance from the mirror. Is this clear? So here,
Yes, sir.
in both the cases, the magnitude of u and v will be equal. In the second case, I'll try to draw a. So suppose this is one of the incident rays, and this is another of the incident ray. Can you say both these rays, incident rays, are appearing to meet behind the mirror at this particular point? So this is basically your object, and what kind of object is this?
Virtual.
Virtual. So basically this will be your object distance, and after reflection the light rays will go like this. So I think ज़्यादा बना देंगे. So this is where the image is formed. Can you see over here? The reflected rays are actually meeting at this particular point, hence the image is.
Real.
So this is basically your image. So can you see first point, guys? U is equals to V. Image distance and object distance are equal in both the cases. Yes or no?
Yes, sir.
The first point is pretty much clear to everyone. The second point is, can you see over here the nature of the image formed and the nature of the image formed and the object is always opposite. Right? So if there is a real object, then virtual image. Real image, virtual object, then real image. Yes or no? So the nature of the object and image is always Is this clear?
Yes, sir.
Third point. Acha, can you notice this particular thing? If this was the mirror and suppose this is your object, I am not drawing the complete ray diagram. This was the image, right? If this was your real object, so virtual image is formed over here. Same distance, same everything. Similarly, if this was your mirror and this was your virtual object, then the image is formed over here, right? Real image. Yes or no, guys? इतना आपने को पता था?
Sir.
Can you see this particular thing? The line joining the object with its image. The line joining the object with its image should always be perpendicular to the mirror. Right? The line joining the object with its image should always be perpendicular to the. Okay. Third point clear?
Yes, sir.
Fourth point. The image is always laterally inverted. What do you mean by lateral inversion? Sideward inversion. Do you remember sideward inversion? Suppose this is A, B, C. So in the mirror, the image will look like A, B, C. Yes or no? If this is like this, and if I write A, B, C over here, then this will become C, B, and A, right? Yes or no, guys? The image is always laterally inverted, sidewards inversion. Can you see over here? Similarly, suppose if I have this is a mirror, a very big mirror. This is a guy who is doing dance classes. So basically, this is the right hand of the object and this is the left hand of the object, right? When he see himself in this mirror, so can you see he sees this image? Although the image is found somewhere over here, but he sees it like this, no? Right, left. Right, he sees it like this, right? So can you see over here, the left of the image is basically the right of the object. Suppose you are standing in the place of mirror and can you see the left of the image and why am I drawing this thing? Assume yourself to be, standing in front of the mirror and when you raise your right hand, the image raises its left hand, right? So this sideward inversion is basically called as what? Lateral inversion, okay?
Yes, sir.
After this, we have the size of image is equal to the size of object. Shall I draw a diagram for this? It's fine. Everyone, is this property also fine, right?
Yes, sir.
Chaliye, theek hai. So with this thing, I'm done with the properties of plane mirror. The last thing which I wanted to teach you for today is basically field of view. Now this field of view can exist for an object as well and as well as an image as well. So first of all, we'll do the field of view of an object. So suppose guys you are the object, okay? No, sorry. There is no field of view of an observer, object. There is first of all this field of view of an image. Understand this, then we'll consider later on. So what is field of view of an image in a plane mirror? Suppose there is this object and let's say this is a plane mirror. Is everyone able to see a finite length plane mirror? Can you see a finite length plane mirror, right? Yes or no? The image for this particular thing will be formed somewhere over here. Ayana, can you see this particular thing, guys? The image for this object will be placed, over here. And can you see over here, guys? This is basically the edge of the mirror. MN is basically what? The edge of the finite mirror, right? So from here, can you see if reflected rays are like going like this? If a reflected rays are going like this, guys, you draw the diagram with the help of scale pencil. I don't have scale pencil and I don't want to waste time by drawing lines like that. So guys, can you see this region? This region in front of the mirror. Can you see, guys, this region in front of the mirror between these two reflected rays which are reflecting from the edges? Suppose if I have any observer, suppose this is, let's say, Mridul. So ye Mridul aaya. Mridul, tell me, if you are standing over here, tell me, will you be able to see this image? Yes or no? Hello.
Which one?
Where if you are standing over here,
Yeah, we'll be able to see.
you will be able to see it over here, right? Satvik, tell me this particular thing. If you are standing over here, will you be able to see this image in this mirror? You have to see this image in this mirror, right? Will you be able to see it? Hello, Satvik here. Shrishma, yes, tell me. If suppose you are at this particular position, will you be able to see that image in the mirror?
Yes, sir.
Array, you won't be able to see it now
The rays are not coming in that
because
direction.
this is the light ray, the maximum edge with which it can reflect was over this, and even this last ray is not reaching your eye. So how will you be able to see this image? Right now. So basically, observer 1 will be able to see it. एक बार थोड़ा जोर से बोलो बेटा.
I first considered observer 1.
नहीं, I am asking for observer 2. If suppose you are at the place of observer 2, will you be able to see the image in the mirror?
No.
No, na. So the definition of field of view is basically this only. It is the region where the diverging reflected rays from an object or image are present. Can you see from this, for this particular image, the diverging reflected rays are present in all these regions in front of the mirror, right? Yes or no? Yes or no, guys? And if our eyes are present in this region, then only that object or image. Sir, why are you using the term object again and again? This can be a virtual object as well, right? So if I want to see this virtual object, then again I need to be in the field of view of what? Are you getting my point, guys?
Yes, sir.
So if my eyes are present in this region, then only the object or image will be seen. Okay? So how exactly will we define it? The region in front of the mirror. For an image, I am trying to, formed. The region in front of the mirror formed between the reflected rays from the extremities of the mirror is termed as the field of view of an image in a mirror. Is this clear, guys? So you can write only, if you will be able to write this definition, then also it's fine, right? Yes or
Yeah.
no? Please
sir.
remember, an observer will be able to see the image inside the mirror only when the observer is in the field of view of this image. Okay, please write this and then we'll draw something. Is this clear, guys? Chalo, question. First case, there is this mirror and there is this object. Second, there is this mirror and there is this object. Third case, थोड़ा सा नीचे बनाते हैं. So guys, I have given you 3 cases in which you have many mirrors and they have been given objects and they have asked you to find out the field of view of the images so found, right? So can anyone tell me this particular thing? If the object is over here, the image will be found somewhere over here, right? By applying the properties of plane mirror, we can do this, right? And then what will you do? Aju. So will this be the reflected ray? And similarly, will there be a reflected ray like this as well? Yes or no? I'm not drawing the incident rays, guys. If you want, I can draw the incident rays, but I need that draw kar raha. Is it fine?
Yes, sir.
So basically, where is the field of view of this image? Can anyone tell me where is the field of view of this image? So any observer who is over here will be able to see this image, right? Similarly, in this case, can anyone tell me where exactly will this image be? So the mirror is not present at after this particular point. Will the image be found? Tell me this particular thing, guys. If the mirror is not, the object is not present in front of the mirror, can you see over here? The object is not present in front of the mirror. Then will the image of this object form?
No.
Also.
It will still form. देखो कैसे? If I try to draw one ray like this, and if I try to draw one ray like this, can you see? ऐसे नहीं.
Yeah, we can see stuff that's not in front of the mirror in the mirror.
Image will be formed, but देखना ना देखना तो वो बात की बात है.
हाँ.
तो So can you see incident ray 1? And can you see incident ray 2? Can you see I'm incidenting the images on the extreme part, extremities of this mirror, right? Yes or no? After this, where exactly will the light ray go? The light ray will go like this, and the light ray will go like this. Yes or no? So can you see these are the two reflected rays? If I try to produce them in the backward direction, both will meet at a point. Let me just redraw it. Are you getting my point, guys? So can you see, guys, this region, this will be the field of view of image I. Is this clear, guys? Is this clear? Can you see image will still be formed and this thing will be there. This last part I'm giving you as a homework. है do it two different images in two different mirror and draw the free body, field of view as well. And also note this particular point ki suppose if you have a mirror somewhere over here and if you have an object still over somewhere over here, then please remember it does not mean that the image will not be formed. The mirror is extending till here only, right or wrong? The mirror is mn, but can you see still an image will be found. वो दिखेगी नहीं दिखेगी, that's a matter of fact later on, right? So always remember this thing. The even if the object is not directly in front of the mirror, still its image will get formed in the mirror. Achha, suppose if you are that object and you want to see your image, will you be able to see it?
No.
No. Why no? Because because you are not in the field of view of your image. That's why. Can you see the field of view of this image is basically only limited till here?
Yeah.
And since you are out of the field of view of image, so hence you are not able to see it. Is this clear?
Yes, sir.
So, but if there is another observer who is over here, then
So that person can see it.
so that person can see it, right? So I guess field of view is clear, right? So please remember, every plane mirror is irrespective of the size of the image, irrespective of the size of the mirror, will always produce a complete image of the object, right? I'll make you write this thing. So note, every plane mirror irrespective of its size always produces a complete image of the object so देखना ना देखना किस पे डिपेंड करेगा whether the point is whether you see the image or not see the image depends upon the field of view of that image, right? Although we can do this thing with the increase in size of the mirror, when size of the mirror will increase, then the field of view of the image can be increased, right? Is this clear, guys?
Yes.
Okay. So in the next class we'll do some questions which are based on this thing.
You will explain the note, right?
No, ये note explained है. In the next class we'll be doing field of view of an observer, and then we'll do some more questions in the next class or next to next class. You know, the plane mirrors will be completed, and then we'll start with the spherical mirrors. I am planning to finish this thing, you know, before
Mid-October.
no, by the way, in the next class we need to complete this thing, no?
Yeah, because we have the exam next week.
So do one thing, guys. Shall we plan one extra class tomorrow as well? People? Hello?
Yeah, yes, sir.
Everyone? Same time, you know, 4 to 6.
So, okay, sir.
Okay.
So I'll drop one more message in the group. Tell me yes. Does
So
anyone have
we
exams in tomorrow?
So we have extra class from 3 to 4.
अरे हाँ तो we talked about this, no? अभी तो 4 to 6 बोल रहा हूँ.
Even I
Can
won't
we
be
have
able
it like 4:30 or something?
4:30 something. Okay. So we'll do it. We'll do it 4:30 to 4:30 to 6. Okay. And 4:30 to 6 we'll do the transformer and thing. You know, we'll complete that chapter. Okay.
So would it be possible to keep it around 6 instead?
6 instead. अरे यार लड़की मेरा एक दिन छुट्टी मिलती है मेरे को बाहर भी जाने को नहीं मिलता उसमें.
So because I can't make it at 4.
अच्छा.
Or I can just watch the recorded
No,
lecture.
no problem. We'll keep it at 6. No problem.
Okay.
So
Yes,
guys,
sir, from
6 to 7:30 है ना?
Okay, sir.
ठीक है.
Okay, sir.
Everyone 6 to 7:30 किसी को तो कोई दिक्कत नहीं ना?
No, sir.
Abel, there, Navina, Darshana,
Yes, sir, no problem.
no problem. 6 to 7:30 I'll drop a message. Same message. चलिए.
Okay.
ठीक है
Thank
guys,
you, sir.
thank you very much. Okay, we'll see you again.
Thank you, sir.
Okay, bye bye.
Thank you, sir.